people are facing new environmental problems every single day. Some of them are small and are only able to affect a few little things, but others are affecting drastically our environment. And all of this is creating a huge impact in our environment. This is known as environmental impact. It is the possible effects caused by a development, industrial or infrastructural project, or by the release of a new substance in the environment.
Research during the last decade has demonstrated the ubiquity of hydrocarbons in nature. Hydrocarbons are sufficiently inert to enter into complex pathways of dispersal involving transport by air, water, and by the food web. Much of the research on the origin and fate of hydrocarbons in nature has concentrated on saturated and olefinic hydrocarbons principally because of the relative ease of analysis by gas chromatography, alone or in conjunction with mass spectrometry. Efforts to study aromatic hydrocarbons in nature are now intensified. The increasing use of fossil fuels and the growing importance of coal and oil shale, whose pyrolysis produces a rich spectrum of aromatic hydrocarbons, pose many environmental and public health questions. However, the formation of aromatic hydrocarbons by geochemical, industrial, and life processes and their dispersal through the environment are still poorly understood. In halogen derivatives, there is a development of a group of compounds known as the freons or chlorofluorocarbons. This group of compounds are exceptionally inert. They are stable and non-flammable. They are largely non-toxic and odorless, and they are gases. This made them extremely valuable in a number of applications as refrigerants, as aerosol propellants, and as solvents. Unfortunately, it is the same inert nature that has caused the environmental damage for which CFCs are now infamous. Scientists realized that CFCs, which had been increasingly used over the previous years, were in fact accumulating in the upper atmosphere. CFCs were interfering with the natural ozone cycle and causing depletion in the ozone layer.
Plastics benefit society in innumerable ways. The benefits of plastics are particularly apparent in medicine and public health. This is because plastics are versatile, cost-effective, and require less energy to produce an alternative material like metal or glass. And the plastics can be manufactured to have many different properties because they can be melted easily and turned into shapes, into three-dimensional figures with molds that can be used for anything we want. The polymers are used in diverse health applications like disposable syringes and intravenous bags, sterile packaging for medical instruments, and also in joint replacements, tissue engineering, etc. It is important to know that not all current uses of plastics are prudent and sustainable. Plastics can produce a lot of pollution. Many of plastics make occasion problems arising from the large quantities that they being disposed of, and there are non-renewable petroleum resources as a result of the increasing of mass production of plastic.
Fuel cells have various advantages compared to conventional power sources, such as internal combustion engines or batteries. Although some of the fuel cells' attributes are only valid for some application, most advantages are more general. Benefits include have a higher efficiency than diesel or gas engines. Most fuel cells operate silently compared to internal combustion engines. They are therefore ideally situated for use within buildings such as hospitals. Fuel cells can eliminate pollution caused by burning fossil fuels. For hydrogen-fueled fuel cells, the only byproduct at point of use is water. If the hydrogen comes from the electrolysis of water, driven by renewable energy, then using fuel cells eliminates greenhouse gases over the whole cycle. Topping the list of concerns is hydrogen burns. In the presence of an oxidizer, oxygen is a good one. Hydrogen can catch fire, sometimes explosively, and it burns more easily than gasoline does. Another concern is that hydrogen flames are nearly visible. When hydrogen catches fire, the flames are so dim and hard to see that they're both hard to avoid and hard to fight. Next, there's the potential for hydrogen to asphyxiate people. Hydrogen isn't poisonous, but if you should breathe pure hydrogen, you could die of asphyxiation simply because you will be deprived of oxygen. Worse, you won't necessarily know that you're breathing hydrogen because it's invisible, odorless, and flavorless, much like oxygen.
Temperature and volume, Charles' law. The Kelvin temperature of a gas is directly related to the volume. When the temperature of a gas increases, its volume also increases. The formula for this law is V1 over T1 equals V2 over V2. If we want to solve for V2, it will be V2 equals V1 times T2 over T1. The next law is pressure and volume, Boyle's law. The pressure of a gas is inversely related to the volume when T and N are constant. If the volume decreases, the pressure increases. The formula of the Boyle's law is P1 times V1 equals P2 times V2. If we want to resolve for V2, it will be V2 equals V1 times P1 over P2. Temperature and pressure, Gay-Lussac's law. In this law, the pressure exerted by a gas is directly related to the Kelvin temperature. V and N are constant. P1 over T1 equals P2 over T2 is the formula used in this law. Now we have the combined gas law. The combined gas law uses Boyle's law, Charles' law, and Gay-Lussac's law. N is constant. The formula for this law is P1 times V1 over T1 equals P2 times V2 over T2. Here we use volume, pressure, and temperature at the same time. For finally, we have the Avogadro's law. In this law, the volume of a gas is directly related to the number of moles of gas. P and T are constant. The formula in this law is V1 over N1 equals V2 over N2.
As a reflection, we think that it is very important to take care of our environment, because without it, we couldn't be able to be alive. Because environment means all the living things and the characteristics of the area where we live. And right now, we are facing different environmental problems such as pollution, deforestation, desertification, extinction of animals, and habitat loss. But we can stop these problems by reducing the amount of garbage that we produce, by stopping the cut down of trees, by outlawing the hunting of animals, and by protecting specific natural areas. We also can help to reduce environmental problems by using all the sheets in our notebooks, by turning the tap off while we're brushing our teeth, and by turning the TV off or the computer when we are not watching it or using it.